Here are some equations about polynomial function. A function f(x) is a polynomial function of degree n if f(x) is of the form as below, where all the coefficients a base I equals either 0, 1, or any number are real numbers, a does not equals to 0, and n is a non-negative integer. The degree of a polynomial in one variable is the greatest exponent of its variable. A leading coefficient is the coefficient of the term with the highest degree. Below are some polynomial functions in general form. For y equals to ax plus b, the degree is 1, and therefore the name of the function would be called linear function. For y equals to ax to the power of 2 plus bx plus c, the degree would be 2, and therefore it will be a quadratic function. For y equals to ax to the power of 3 plus bx squared plus cx plus d, the degree would be 3, and therefore the function will be called a cubic function. For y equals to ax to the power of 4 plus bx to the power of 3 plus cx to the power of 2 plus dx plus e, the degree will be 4, and therefore it will be known as a quartic function. The largest exponent within the polynomial determines the degree of the polynomial. Here are some ways to identify polynomial functions. First, you write the function in standard form and state its degree, type, and leading coefficient. Okay. Here are the solution. The function is a polynomial function. Its standard form is f(x), which is equals to negative 3x to the power of 4 plus half x to the power of 2 minus 7. It has a degree 4, therefore it's a quartic function. The leading coefficient is negative 3. Here are some examples of polynomial function. Zeros of polynomial functions. If f is a polynomial function, then the value of x for which f(x) equals to 0 are called the zeros of f. These values of x are the roots of the polynomial equation, f(x) equals to 0. Each real root of the polynomial equation appears as an x-intercept of the graph of the polynomial function. How to use zeros? There is an order, degree at each x-intercept, the degree of each bracket. Steps that are required to follow are: first, you have to identify the zeros. In this case, it's negative 3, 2, and 5. Then use general formula of factor equation, which is f(x) equals to ax plus 3, x minus 2, x minus 5. Then you have to find the order by isolating the point. If its linear is 1, quadratic is 2, and so on so on, f(x) would be equals to x plus 3 to the power of 1, and x minus 2 to the power of 1, and x minus 5 to the power of 1. Use the given known point, which is 1 and 8. 8 would be equals to 1 plus 3, 1 minus 2, and so on so on. And therefore f(x) equals to half x plus 3, x minus 2, and x minus 5. What is an even function? It is a function that satisfies all the properties. Here is an example of even functions that have line symmetry in the y-axis. To figure out an even function, the exponent, which is the exponent of the variable of each term, has to be an even number. What is an odd function? Odd function is a function that satisfies all the properties for all in its domain. To figure out an odd function, the exponent of each term has to be an odd number. When the expression contains a constant, it would be like this: x to the power of 3 plus x plus 1. Here is an example of an odd degree function. Odd functions have rotational symmetry about the origin. And now I would go on to 1.4, which is transformation. The basic general formula of transformation is y equals to a bracket k x minus d to the power of n plus c. And here are some compressed and stretch formulas. A represents vertical stretch or compression. K represents horizontal stretch or compression. D represents horizontal translation, while C represents the vertical translation. A would be the reflection on the x-axis, while K would be the reflection on the y-axis. Here is an example of a transformation. To describe the transformation y equals to negative 3x plus 1 to the power of 3 plus 5, it is a cubic function. It is vertically stretched by a factor of 3, and its reflection is on the x-axis. It is horizontally translated to the left by 1 unit, and it is vertically translated upwards by 5 units. For the second example, you can find the transform equation of y equals to x to the power of 4. It is reflected in the x-axis, and it is vertically stretched by a factor of 2. Horizontally translated to the right by 1 unit, and it is vertically translated upwards by 1 unit. Therefore, y equals to minus 2x minus 1 to the power of 4 plus 2. Here is a summarized graph for transformation. A would be smaller than 0, then the reflection will be on the x-axis. If k is smaller than 0, it will be a reflection on the y-axis. If a is bigger than 1, it will be vertically stretched by a factor of a. And if k is bigger than 1, it will be horizontally compressed by a factor of 1, or k. If 0 is smaller than a, and if a is smaller than 1, vertically compressed by a factor of a. If 0 is smaller than k and smaller than 1, it will be horizontally stretched by a factor of 1 or k. So basically, if a is bigger than 1, it is stretched. If 1 is bigger than a and also bigger than 0, it is compressed. If k is bigger than 1, it is compressed. If 1 is bigger than k and also bigger than 0, then it is stretched. And now Chris will go on to chapter 1.5 and 1.6.